Hi, I'm Claire. I was also in Mr. Fortin's Algebra 1 class, and today hopefully I'll be able to teach you a bit about using function notation. So I know function notation sounds like a fancy term, but hopefully it'll be less daunting once we get into it some more. So I'm going to tell you about some main ideas of this, and it would be great if you could write these down in your notebook because it's really great for retaining information, and if you ever need a refresher, you can go back to your notes. So the main ideas, the use of function notation allows mathematicians to name certain equations. So for example, if you see this, then you would call this function f, because this letter right here is f. But if that letter were g, then you would call it function g. And same, etc. for any letter that this is. Okay, so when you see function notation, you will usually see this in the place that y normally is. And this is pronounced f of x. So when you see y in an equation, it would be y equals, and then whatever y equals. But instead, you would be saying f of x equals, and then whatever it equals. And if you're told what x is, then simply substitute that value for x, the input, and solve for f of x, the output. So what you would do is anywhere you see x, you would plug in what value you have, what you were given, as, right there instead of x. And I know this sounds confusing, but we'll get into it a little bit more down below in the examples. So this is also the same for when you are told what f of x equals. You'll simply substitute that value for f of x, which is the output, and solve for what the input has to be. So anywhere you see f of x, you would plug in that number that you're given that equals f of x. And again, it sounds confusing, but we'll go over it. And this is no different than solving for y or x when you know y. And for above, that's no different than solving for y when you know x. So really, it's what you've done before, but in a little bit more intricate way. So we'll see. So now we're going to work on some practice problems, and hopefully it'll make some more sense because it's a little confusing when you explain it in words. So given the function f of x equals 2x plus 1, a, if the input is 5, what is the output? So first I'm just going to annotate it a little bit, write my notes, because this can help us understand the problem a little more sometimes. So the input in this case, it just means x. That's what it means. And the output means f of x. So since this is what the input is, 5, if 5 is just what the input, or 5 is just what x is, then we plug in 5 anywhere we see x. So we're just going to rewrite this f of 5 equals 2 times 5 plus 1. So now we're just going to simplify this. So we keep writing f of 5 and then we write 2 times 5 equals 10 plus 1. And then next, we're just going to keep simplifying it. And we get our answer, which is f of 5 equals 11. Awesome. And now we're going to move on to B. So if the output is 101, what is the input? And I'm going to annotate this again, just to make it a little more simple. Output, meaning f of x, okay, sorry, Okay, and then the input meaning x. So now we're just gonna plug in, we're just gonna plug 101 in as f of x, just where it is over here, because that's what it equals. It equals f of x. So we're gonna write, instead of writing f of x, we're gonna write 101 equals 2x plus 1. And just as you learned about previously, we're just going to solve this like a linear equation. So first we're going to combine like terms. And I don't see any like terms on either side. So we're good in that end. And now we're going to move all the x's onto one side. But look, there's none to move. So because there's none on this side. They're already over here. So the only thing we really have to do is leave it alone. So we have to isolate x. And how we can do this is by taking away the 1. And how we do that is we subtract 1 from each side because it cancels 1 out. Because 1 minus 1 equals 0. So we're going to subtract 1 from each side. And that leaves us with 101 minus 1 equals 100. (100) equals 2x. And to further isolate x, we need to divide both sides by 2. So 100 divided by 2 is 50. And 2x divided by 2 is x. And there's our answer. 50 equals x. And we're going to check that just because it's always a good idea to check your answers. I'm going to do it over here because I don't have much room over there. So how we do that? So 50 equals x. So anywhere we see x, we're going to plug in 50. So 101, because that's what we found out equals f of x, like right over here. We're plugging in 50 to wherever the x we see is right over here. 101 equals 2 times 50 plus 1. Okay, so that leaves us with 101 equals 2 times 50, 100, plus 1. And then that just leaves us with 101 equals 100 plus 1, 101. And awesome, that means that we are right. And now we're going to do another problem. So for our next practice problem, you're welcome to give it a try on your own if you feel ready. But if not, totally cool, we can do it together. So first of all, let's read the question. Given the function g of x equals negative 4x minus 2, a, find g of negative 5. So how we're going to do that is that we see this, just like this, except negative 5 is where x is. So that tells us that wherever we see x in over here, which is right here, we're going to plug in negative 5. So let's do that. And then we can solve for what g of negative 5 equals. So these are very similar to the last ones, except they're a little more complicated, just because the wording is different, or yeah, the symbols are different. It's using more symbols instead of words, so that can be complicated. So negative 4 times negative 5 minus 2. So we're going to keep writing g of negative 5 equals negative 4 times negative 5, 20. minus 2. So that means that g of negative 5, ooh, sorry for the strange 5, but anyway. So 20 minus 2 equals 18. So that means that g of negative 5 equals 18. Okay, awesome. Now we're going to move on to b. So if g of x, right here, g of x is what? Oh, no longer arrow. G of x is this. So we just need to plug negative 33.5 wherever we see g of x, which is right over here. And then we can solve that to find what x is, just like in the last problem. So we're going to rewrite negative 33.5 equals negative 4x minus 2. You see how I just took this from over here? Then we're just going to solve for x like we do normally. So how we do that is now we're going to add, so first of all, let's look for some like terms. Do we see any? I don't see any. So now what we're going to do is isolate x. And there are no other x's on this side. So we're good on that end. But now we have to get rid of this 2 so that we can isolate this. And let's do that by adding 2 to both sides, because that makes this equals 0, therefore canceling it out. So then we'll add 2 to this side. Okay. So then okay, equals negative 4x. And now what we're going to need to do is divide both sides by negative 4 to further isolate x. I'll just put some parentheses around it to make it a little clear. Hopefully that looks clear for you guys. Okay. Negative 4. Cool. So now what we're going to do, I'm going to need to use a calculator. Let me just get that up. I'm going to plug this in. So I'm going to say negative 31.5 divided by negative 4 equals, not a very fun number, but that's okay, 7.875. And that equals negative 4x divided by negative 4 just equals x. And there we go. That's what x equals, hopefully. So I just checked my work off camera just because I thought it would be boring to see me struggle trying to draw the whole thing. But so here I checked my work and you'll see that it says negative 33.5 equals negative 33.5. So that means that we got the right answer. Awesome. Here's the answer. And that's all. I hope that helped you understand a little bit more. I know it can be a little confusing and daunting, but I hope you understand. And yeah, if you ever need help, don't be worried to ask. And have a great day.